But
Look up cows.
oh yeah, I don't want to go there. Oh. Okay. You guys are funny. Okay, here we go. I would like to introduce this idea of solving equations with a very, very simple equation and talk about the context about what we're supposed to do. X is 3. Okay? So, did you guys get X is 3? Yes, X 3. Now, how can you check to make sure that what you got is exactly right? Yeah, you can substitute. That was awesome. So 3 times 3 minus 5 is 4. So 9 minus 5 is 4. Yep, 4 is 4. I have found the one real number out there in the world that makes this a true statement. I'm feeling pretty good about myself. You guys okay with that? All right, so there is a larger philosophy going on here, right? And speaking of stuff, let's try this. Okay, 3x divided by x minus 1 plus 2 is equal to 3 divided by x minus 1. Oh, man. Life just got something very, very important. There's something very important that we should consider, and it is this idea of a domain. I'll tell you, how do you figure out a domain for this thing, right? Well, in mathematics, right, we are not allowed to divide by what particular number? Yeah. Dividing by 0, people get upset. They start to be criticized as witches. You cannot divide by 0. So, our domain, I'm going to teach you how to write this, is x such that x is not equal to 1. Now, I'm going to tell you how to read this. This is something you have never seen before, okay? This is read like this, x such that x does not equal 1. That's how you read this when you see this, okay? The squiggly lines include the sets. That mean you're talking about a variety of things. Now,
That's what I said.
how did I get a domain of all real numbers x except for 1? Where did I come up with that? I didn't pull it out of the air. There's a certain thing that I saw. What did I see? Very good. If x was 1, the denominator would be a 0, because 1 minus 1 is 0, and I'm not allowed to do that. So I need to consider this before I do anything else, such as all those wonderful suggestions that all of you had. Now we can go ahead and solve this problem. You guys with me on this? So I made a big deal about the domain.
Find out what it can't be.
Yes.
That would have been right.
Yes, find out what the denominator is not allowed to be. There you go. So I need some more space, so I'm going to rewrite this, okay? And then we're going to take some, it's just 3x, right? So now multiplying by x minus 1, which is the denominator, it clears all of the fractions for us, and it makes our problem a lot easier. Would you agree? Now we can easily solve this and say, okay, this is 3x plus 2x minus 2 is equal to 3. Am I going too fast? No. Okay. So 3x plus 2x, well, that's 5x minus 2 is equal to 3. I'm doing good so far. So that means that 5x is 5. X is equal to 1. Awesome. Sweet. I did it right. I got 1 as an answer. I must have done it correct. I can go home and, like, be cool.
Go check it.
But this is exactly what my domain is not supposed to be. Therefore, the real answer implies there are no real solutions. What? Scooby Snack? How is that possible? Alright. There are no real solutions. So it is very important whenever you have a rational expression, you must consider the domain. Otherwise, you would have done all this stuff, said the answer was 1, moved on, and you would have missed the big overlying picture. You guys with me on that? And I don't want you guys to miss that. Okay, cool. Okay, third box here. Third box is solve by factoring. Okay, now if it says to solve by factoring, that we should do that, okay? So, I'm going to give you x is equal to 0. Are you guys okay with that? Okay, I'm going to go with this. I like this one. X squared minus 4x equals 0. So now, can I factor anything out? Yes, x and x minus 4 equals 0. This brings me to a very important point that's known as the 0 product property. Very good. Okay, now the important word there, ladies and gentlemen, is the word product. Product means multiply. There is no such thing as the zero-sum product property. I mean, zero-sum property. Sorry, I messed that up. Okay, it has to be multiplication, and here's why. All right, I have two numbers, x and x minus 4, that are multiplied together to give me a 0. So what does that mean? If I multiply them and I get 0, that implies something very important. What is it?
It equals 0.
One of those has to be 0. So I set both of my numbers equal to 0. So either x is 0, sweet, there's one of my answers, or x is equal to 4 when I add to the other side. So are you noticing now that I have two possible answers? So because I have two possible answers, I need to create a solution set. This is a solution set. Okay? It's got the squiggly brackets
What is it?
and 0, 4 are my. Okay, here is the U-try, okay? It is 1/2 times p plus 5 minus 4 equals 1/3 times 2p minus 1. Everyone goes, P? Like P, like what's wrong with P? How about M and Q? Don't leave them out. I mean, I want to give equity to all letters, okay? All right, see if you can solve that one. There is a hint. Do you guys want the hint, or you want to think about it?
Oh, I saw this problem in the thing.
What's the hint?
Multiply by 2 and 3.
No.
By 6.
Yes. Multiply everything,
Here's all
all,
the things we took notes on. Yeah, it's in the book.
by...
It's not.
Okay. All right. Let's take the hint. Let's do this together, okay? Let's multiply everything by 6, okay? Now, let's do this together. What is 6 times a third?
2.
2. So this is going to be 2 times 2p minus 1, okay? What's 6 times negative 4?
Negative 24.
Negative 4, done 24, good. What's 6 times a half? 3. So this is going to be 3 times the quantity, p plus 5. Are you okay with that part? Question, yes.
Why didn't you multiply it by the ones in the brackets?
Oh, I love this question. This question comes up every single year. Okay, I want to do a little experiment with you on the left-hand side, okay? Let me do this. Let's do 1/2 times 4 times 10. You with me on this so far? Okay, now, what is half of 4? 2. What's 2 times 10? 20, good. What's 4 times 10? 40. What's half of that? 20. So, notice we did not take half of 4 and half of 10 to get... Okay, all right. All right, so here we go. Continue on here. So this is 3p. 3p plus 15 minus 24 is equal to 4p minus 2.
That's a
4p minus 2. Let's get this quickly here. So 3p minus 9 is 4p minus 2. Therefore, I'm going to have p is equal to negative 7 once I finish that whole thing up. All right? So that's the answer that we should have gotten there, okay? All right, here we go. Last 2 boxes here, quickly as we can. Here we go. Let's do 2y plus 1 times y minus 1 equals y plus 5 times 2y minus 5. All right, we'll do this one together. So the first thing we can do is we can multiply both the left and the right-hand side to get the following here. 2y squared minus 2y plus y minus 1 equals 2y squared minus 5y plus 10y minus 25. Is everyone okay with what I'm doing so far? Okay, now I can take advantage of the fact that I have the same exact term on both sides of my equation, so I'm allowed to get rid of them because I still say balanced. Okay? So this gives me negative y minus 1 is equal to, what would this be, 5y minus 25? You guys agree with that?
What did you do with the negative 2y?
Negative 2y plus y is negative y.
What the?
I combine like terms. These are like terms, and these are like terms. That's the only thing I did. Okay? Thank you. That's a good question. So that means that I get this. What am I going to do here now?
Add and subtract.
Add and subtract. Good.
Add the y, add the 25.
Add the y, add the 25. Okay, good. So let's add y to both sides. So that means negative 1 is equal to 6y minus 25. So that means 6y is equal to 24, so y must be 4. Okay, that one wasn't so bad.
But what about the... We don't have to do the domain for this because there wasn't a fraction.
Correct. Correct. 100% correct. So the domain is all real numbers for this one. Yes, very good.
Could we have done it for the other one?
I think we've only had one with a fraction because, yeah, this is 1/3, so there's no variables on the bottom. Okay? All right. Okay. And the last one, let's do 3 all over x minus 2 is equal to 1 over x minus 1 plus 7 over x minus 1 times x minus 1 times x minus 2. Here we go. So let's do it. Okay, when we do that, we get the x minus 2s will cancel out, so I get 3 times x minus 1 is equal to 1 times x minus 2 plus 7. Wow, that is so much easier and nicer looking than anything else. So 3x minus 3 equals x minus 2 plus 7. So that means that 3x minus 3 is equal to x plus 5. So 2x is equal to 8. So x must be 4. And x equals 4 does not interfere with our domain at all. So we are okay to state the fact that x does equal 4. All right.